Need to find out where I put that tin foil. This ought to work right here. So it'll be enough. Sweet. Hello, hello. What's up? Here we go. You'll see the power of the simultaneous thing going on here of the miles per hour junior, the M.P.H.JR. So I like to start it before I clip it. How many magnets? 6 altogether, but it's at 120 degrees.
I just made that a poll question, so hopefully nobody watches. Well, hopefully everybody watches from the beginning.
Yeah, we're getting a little shaky. Because it's going so fast. I'm not getting a good tack reading with that strip I put on there. It said 8,000. Oh no, 800. Okay. Dang, my eyes are 8,000. My eyes are terrible. I knew it didn't say 8,000. I just thought it wasn't broken somehow. Alright, so that's going up really fast with just one drive hooked up. $920. Like if I hook that other one up, man, it's gonna fly, fly. But you see, I had a problem. The magnets were exposed. $970. So I had a problem, and that was that the magnets were exposed. But then I'm like, I had made several duplicates of this rotor. So I'm like, well, I'm just gonna put another one on top so that the magnets would bond. Because right now the only thing keeping the thing like the way it is it's 2 neodymium cubes attracted to each other, which is a pretty strong attraction. But I don't want to take any chances, so I'm tripling that attraction by bonding the 3 magnets together. And I don't know if you're changing you or if you're changing your environment. I think changing your environment would be a lot easier to do. And I think that's what it just, So like the bubble that you create around you is changing your environment. Right? So if you create a null zone in gravity around you, that's changing your environment. You're not changing how much you weigh, really. You're changing your environment from an environment with gravity to an environment without. But it might be the same thing. We might be speaking the same language actually, but we'll not this a different language about the same thing. That's just how I like see it. You're not really changing anything except for the space around you, which is, that's huge. I'm not saying anything other than that. That's my opinion, and I might be totally wrong about that because I don't know anything about it. But if you can imagine, there's two cubes stacked on top of one another, with the north facing down, so it's doubled up. So it has a stronger force against force, which again leads to torque and speed being increased. And when I put the three other magnets on here, to change it from 3 to 6, we reduced the air gap as well. So I mean that alone is worth, a lot. All right, it's going pretty slow, about 600, so we'll clip this one. $757. $900. $1050. $1,100. It's high on the shaft. I'm gonna cut it back. You can see it wobbling there. It's really high. So I can't let it run. I could get up there like, if I had like maybe a 10mm shaft or a 3/4 inch shaft, then I could just let it run, let it buck, man. This thing could probably get up to 2,500 maybe. Because I mean, typically you let your motor run for about 10 minutes or so before you even start measuring on it. That was like 2.5 minutes, maybe 30 seconds, maybe some attempts. And I haven't even got a chance to play with the pots yet. I mean, there's no reason to play with them. It's going so fast. But if I did play with them, I'd probably generate a hell of a lot more energy. Let me see what we got left in this battery over here.
Society says Why store energy in the mechanical rotation if it has a natural loss or leakage over time?
Because I'm not storing the energy, I'm using it.
Morgan says, "What's up, guys?
What's up?
Going on? All right."
No, and I understand the question, but all this is spending of energy. There is no saving or storing going on here, really. There's a lot of experiments going on, and I like watching things spin, so I'll never stop doing this.
And Mike does in the house. Morgan says, "I love the Tesla coil on a bench."
Here we go, Tesla coil.
He says, "That's my jam."
You crazy? You crazy?
He says, "That's my jam."
It's a thunderstorm, man. People wouldn't tell the difference. It's like,
Society says those things are cool. Morgan says, "Very cool with some glasses."
oh man, I love playing with it. And since it's this at this stage, it's pretty harmless. So I love playing with it. I'm gonna spin it the other way this time. So we're going counterclockwise this time. You hear how violent that is when I turn the second one on? It's like, let's go. It's like it literally pushes it up because of the double magnets. It's like, whew. And so far, it's excelled every time. And this is without playing with the pots yet. I haven't even touched the resistance, and it's all at 0. That's probably why it's like that. It's those ceramic bearings. I'm not really used to them, and they sound like a train, kind of, almost. It's smooth, but it's like it does sound different than other bearings. So it feels like it's gonna fly off the hinges here.
Yanni's in the house.
Yanni! So this is it, man. This is the final version.
Those mini Tesla coils can induce voltages in piezoelectric buzzers or quartz.
Yeah, I got a pyramid with orgonite right behind here, and it's also got quartz in it, rose quartz, and some sort of symbology in there. But it's in acrylic resin. This is a fluorite sphere. What do you think fluorite will do? Anything? Or does it gotta be quartz? You okay?
Mm-hmm.
Alright. Cause I got some quartz.
Morgan said, "I often thought of building an inverter powered pulse motor."
Sounds awesome. So here's my quartz. It's a little cracked.
It's a nice piece.
It's 6 faceted, so it's hexagonal. Pretty sure it is. Yeah. So let's see here. Should I just put it right here like that?
Yanni says it's almost a wand.
Yeah, the wand is this one right here.
Oh yeah.
Jasper Knight or something like that.
We gotta figure out. I forgot that.
Might be jade, actually.
Bring him
Oh man, I'm scared to turn it on, dude. I don't even know what's gonna happen.
over.
Oh, all right.
Oh, okay, he's the Quartz.
Yeah, it does go attract straight to the
Quartz.
both of them.
Oh man.
Both of them. You see it, Jonathan, in the middle of the spike instead of the tip. Wow, man, that's freaking amazing.
Whoa.
I'm glad it's raining right now. Or there might be, police at the door. That's popping. That's really popping. But yeah, man, both of these stones here, probably even the fluorite, will attract. I don't know what it would necessarily do. Each one, I guess the quartz does the most, or works the best with it, and I don't even know if it needs to be that close to get the energy off the Tesla coil. I don't think so. But this is really small. This is a tiny one. Here, let's feel this. It doesn't feel any different. It's been a while since I turned it off, though. That's sweet. That is really cool. The fluorite ball. So, I don't know, I have an idea. I'm going to turn the resistance on 5 turns. Now I'm going to start it up and we'll see what happens. I'll turn this one up a little bit too. Oh, we just lost, here, I gotta put this back on. It's raining nice outside, that's good.
Yeah, it is.
The pond's gonna flood.
Yeah, it is.
So the amount of resistance that I put on it is enough to like totally stall it out almost. Check that out. So I'm gonna back it off a little bit at a time here. Now, even though I'm gonna be doing pulse motors forever, I'm probably gonna start doing other stuff too. So it's not like I'm shunning anything or saying no, nay, whatever. I'm just saying, you know, I might get started doing stuff too, and I got my own opinions about things. And seriously, I think that some of them should be looked at. Others are definitely psychosis. But yeah. Some really good ideas floating around here. Oh, I think my multimeter is dead. Oh no. Yep, and the only way to charge it is to take the plug off the phone. Oh no. Yeah, unfortunately.
Oh man, it's even raining even harder now.
You hear me talking about it. All right. I'm just so like thrilled right now that I got something that I can pretty much call done. And this will run, see, it runs two ways. It either runs with the battery and a closed loop system on both sides, or you can take a power supply on the input on both sides and put the lamp here on the output. And you can run it like that, and you can visually see the difference in power from when you turn each pot, because both pots will change both lights. You get what I'm saying? It's like these two motors are intertwined when it's hooked up like this. They're so connected that it's, well, everything you do to one affects the other. But then you can take a slider that all the way to the top, man. You can do that now because you got two that are working in tandem. And what I mean is there's two motors here working in this one coil. It's compact. It takes up less space than doing it in two coils. And as you can see, it's got the same equal power or more power than doing it the other way.
Oh man, it's raining hard.
But as you can see, the problem that I have is that the coil is that big. So I gotta have it at least this high off the ground. If I could put it on the ground, you know, if I run it in a radial form, I wouldn't be having this stability issue at all. It wouldn't be this high. It wouldn't be riding on this shaft this high with it being that skinny. It's not the smartest thing to do, but I wanted to try it in axial flux mode. But I think I might end up doing a radial thing. Yeah, I mean, that would be really cool. I don't know if I can make it, it might not be the same. I might just take the top off altogether and just run with the one and literally just put it on the bearing on the flange that's in the table and have it literally be like 1.5 centimeters off the table And that way when it gets going real fast, it's got that whole shaft to keep it in line instead of just, and every little bit of like weight differential is going to frick with this thing because the shaft is a 1/4 inch and it's that high. There's this much shaft above the rotor. It's like, it's so, and I mean, it's not about how much shaft is up there really. It's about how much shaft is below. Because the leverage like really shifts when it's high on the shaft. But I like it, man. I like the axial flux. I like how well this works. I like the difference in, you know, the resistances. The pots are working awesome. Like they're going off without a hitch. This is the best that I've had working with pots. And that's good, man. The more fun I have, the more I want to use them, the better off I guess I'm gonna be in the long run. Yeah, I haven't had any issues really running with this. This is project M.P.H.JR, M.P.H. Jr. For let's see here. So I guess it's going to attract to anything that's near it, pretty much. But I guess the quartz utilizes that the best way. It's not about the arcing that attracts. That's cool that happens, but there's energy beyond that that I am more interested about. That is fun though. I like playing with that. Yeah, I'm just wondering if I did that right enough. Oh, I'm working with the wrong tool. Because they're cubes, right? So if you put north facing down, then you got an orientation going the other way, right? So either east or west is going to be facing outward, or you're going to have both facing outward. Okay? And if both are facing outward, that's a good thing, because your east and your west can act as a fallback array. And that just adds a whole nother level. It's probably what's going on here. It adds a whole nother level of like speed and efficiency to running the motor. It knocks the cost down by like 200 milliamps, depending on what your cost is. Usually for me, it's about 200 milliamps. Yeah, I don't. And I mean, why ask why? That's a really good question right now. Why ask why? And you should ask yourself why you're asking me why I'm doing this. Just for a second, ask yourself why you're asking me. If you really want to know, that's awesome, and I can tell you that, and I've said it before, I started off with like levitation discs, magnets. I put a lot of magnets on the edge of a disc and more than one disc, and then I could levitate them on each other, and I could spin them, but only with my hand, right? So I started asking questions on YouTube. How can I, make this move without me moving it? And this is one of the you know, rabbit hole paths I took, man, and this and it worked. It worked like the first time I tried doing it. Of course, I started with the reed switch, and then I bumped into the crew, and they showed me the ropes, and I learned very little so far. And I don't think people understand how like very fresh I am into this stuff. And I have no formal education in electronics or anything that has anything to do with any of this. And what I'm saying is that, yeah, I built this, but there's a lot of things I don't even know about it. I'm not afraid to admit that. And then there's people out there making fun of me because of it. Like, God. Good Lord. So cool. But yeah, I don't know, man. I think it's great. People getting into doing this. I am aware there is another facet to this situation, or another side of the coin, where there are a lot of people out there that say that the people doing this whimsically is a waste and it's a terrible business. And I say, from a logical perspective, that's absolutely true to a certain extent. But then from the opposite perspective, or an opposed perspective, like an inspiring perspective, or an inspirational perspective, a whimsical build can lead to the key, the answer, and what everybody's looking for. Like, oh my God, why didn't I think of that? It's like you have to go outside the box. There's nothing in the box, man. It's all been done before in the box. So you gotta go outside of the box. And I know what that sounds like. And it's like, a lot of people are doing that right now. And it's thrilling me, man. I mean, I'm watching some pretty awesome stuff.
1,000 views.
Awesome. I'm watching some pretty awesome stuff, and it's thrilling me. I build pulse motors because I like watching things spin. I like playing with magnets. I like lots of things, but there's some stuff that I don't like, but we're gonna keep it. Not like the boys. We're not gonna do the boys thing where we all are like mind and gang up on other boys. That's not what we do here. Woo. Actually, it's just me and my brother right now, and we love doing pulse motor stuff, and we don't diss on anybody's stuff, really. I think all the stuff is cool. I think some of the people might need to, I don't know, man. I am very, I'm going to take 5 minutes. I'll be right back. it's starting to pick up speed. Starting to fight through the resistance I put on it, which will generate a lot of electricity going back into the batteries. That's awesome, man. That is so cool. Can't beat that, man. That's starting to truck now. And if I could turn that back on, I bet that would be stable as awesome. Just be awesomeness. And it's like, but things like this will be taken apart within a week. So I'm trying to get as thorough explanation out as I possibly can on video and live stream, and just any kind of online documentation that I can get. And I got this solid state thing here that I'm working on. I think the last reading I got off that was like 345 AC volts off of 5 DC volts, which I think is pretty awesome. So why don't we check that out real quick? Get to play with the signal generator for a second. Oh, we're charging a battery actually. Do you want to do that, or do you want to get the reading off the coil? Let's charge the battery. Do that. Okay. I'm just going to keep turning up the frequency. There we go. We just started charging at 52 hertz. So that's just a little bit though. Let me turn this up more. Look at how fast that's going now. Wow. That's awesome. 84. So what we're using as a generator coil is a Litz coil. It's got 100 strands of 38 gauge twisted up to be an 18 gauge wire. But it's only like 50 turns around that spool. You know, it's not very many turns.
Have you ever seen serpentine coil motors?
Not the motor. Well, I've seen, yeah. God, I forget his name, but he's an English guy from the UK, and that's how he taught me how to do rodent coils. He taught me how to do lots of stuff. He was one of the forerunners in the early days where this was really taking off.
I remember seeing him do
Smith or something. Murray. That's it. And Gerald. Gerald was another early mover because I remember him playing with his geometry coil like way back. Not really too far back, but I remember him playing with it like before I saw a lot of other stuff going on. Always charging a bunch of batteries at the same time. He was doing that. The meters that he had like a bunch of meters hooked up to it from different points. And that was awesome. See, this right now, there's no power going into the rotor in the middle. So I'm thinking that the caps that I have going across are contributing to its motion somehow. Or maybe it's just really a lot better rotor now that I put that top part on there.
He says, yeah, he says the guy has some good videos. I like the simplistic design of his generator.
Yeah, absolutely. We're at 240 hertz right now. Now see, I think what it does is it gets equal. Then you gotta change the resonance and force it. You gotta change the frequency and force the generation to continue. And then if you go too high, it'll start going down. We're at 353 right now.
Sting says I was an electrical engineer 42 years.
That's awesome. That is freaking awesome. Heck yeah. You do realize that this is picking up in speed right now and it's not connected to the power. I can hear it like hissing. Oh no, that might be this power supply in the back here. See, man, that's my hearing and everything. It's like playing tricks on me. Had to lean in to get that one right. Okay, starting to go down. 424. Now let's turn up the voltage a little bit. Five volts in.
Janice Carroll is in the house.
Hello, hello. Okay, it's going down. So we were right at where I normally have it. It's about 427 hertz, 24 hertz. Yeah, there we go. Maybe we go down from there. Oh, I think something. Okay. Going up a little bit. I can hear it like buzzing. 368, 378 hertz. Let's try this. Three six nine. Oh, it went up to 1040. What do you know?
1040.
Yeah, 10. The battery is
Oh, got it.
12-volt battery. It's
Charged.
yeah.
Alright, society says, I'm thinking if you measured the wave of the serpentine coil, you could match the hertz to square wave shape of the coil's peaks and troughs.
Yeah.
So
I'm planning on experimenting with the serpentine coil for sure. I gotta, put a lot of thought into it actually, and just decide, how big and the gauge and whatever. Even if it's not important, you still have to make those choices.
did someone say 69?
369, that's right. And then look at it go, man. It's charging now. So this circuit is an SSG with gen mode, running on the last three is 200. And it's on a 3/4 turn pot. That's 1K ohms. So this is this circuit alone, and it runs it pretty well alone by itself.
Brazil is in the house.
What's up, Brazil? All right, so yeah, as you can see, it's kind of whipping, but it whips so much, like there's more torque involved in the whipping when I hook the next one up. But I know that it's just a 12-volt parallel system. It's not really parallel; they're just working in tandem. But nothing above 12 volts is going on here. Yeah, so I think I'm gonna set it up on the ground soon. It's maglev right now, and it'll probably move. I don't know what I'm gonna do about it actually. This is so fun. The maglev makes it move so smoothly on those ceramic bearings, and then this is just keeping the magnets that are sitting there in place. It's very light. The only weight in that entire thing is coming from the magnets, really. $10.44. You think we should? No, 369, man. That's it. We can go a little lower. 360.
Does the coil being pulsed also run off the battery?
Yes, both of those coils, well, there's two, it's running off of two batteries. Kinda, yes. This coil right here is hooked up to two circuits, it's therefore got two power supplies. Only one of them was hooked up though. I can hook them both up if you want to see that. And they're closed loop systems, so they're not like wasting energy at all. They charge their own batteries. Of course, you have a little bit of loss. Like, so what though? You got a wall charger. You can use the wall charger to charge your loss. I'm just doing experiments, man. I'm not in any game or competition where I'm trying to make these two batteries last forever. I'm not trying to do that. I'm just, they're running on their own batteries, they're charging their own batteries. And that's good for right now, I think. I mean, when this thing gets going really fast, doesn't that mean that the Bedini SSG works better when it's running faster? I mean, right now there's no power going into that thing. So it's like, doesn't have any power going in right now. I will put the power in.
Greetings from Baltimore City, Maryland.
Hello, greetings. We're from the D, Michigan.
Apex Master.
Well, there's a lot of resistance on it right now, so it's probably not going to get as fast as it normally would. But as you can see, man, it's moving right now. 1141, 1267, 4. Oh, that's not right. Oh, 786. Keep missing that decimal point. And there's a hefty amount of resistance on this right now. 893, 910, 925. This is how the rate is increased. 961, 970, 978, 1,000. And that was a steady, it's just catching its stride, really. So I agree with letting it run for 10 minutes before you start taking measurements. Because that was just starting to get moving, but due to the fact that I built it all on a 1/4 inch system, this shaft is a 1/4 inch, man. And just the way it's moving right now, it's shaking the shaft a great deal. This is pegboard that it's all in, screwed into. It is going through a 2x4 that's underneath there, but that's all loosely put together. So I don't want to have like a catastrophic failure on my brand new success. Let's take a look at our, oh, that did go up, okay. 1047, It's charging like very slowly. I do want to see something though. I want to see. I want to hook up to the AC side of this bridge rectifier with the meter. I would hook up the oscilloscope to this one, but it's dead right now. Uh, my other meter is dead too. Alright, here we go. Alright, it might be like intertwined right now with, yeah, maybe that's bad. Here, what if I do this?
How does the timing coil work?
I wound it parallel with the drive coils, and it works by the magnet generating the electricity when it passes by it. And so it trips the base and the transistor, and the transistor connects the collector to the emitter, and it closes the circuit. But I made it a 32 gauge, so there's two 32 gauge strands in here. One goes to this circuit, one goes to this circuit. They each get their own trigger strand. Best way I found to solve the issue of what happens when you try to share it. Okay? And then each one gets a drive strand, which is a 20 gauge strand, which is probably not over unity, but it's close to unity, and I mean really freaking close. And that's running it on a closed loop system where it's being charged and driven off the same battery.
It says, I see.
Alright.
He gets it.
Cool. Sweet. So,
Good explanation. That's what that means.
alright. Alright, so right now, the amount of energy that's coming out the bridge rectifier and the AC connection is 77.6. That's a lot lower. We're going to try and find the resonant frequency right now on this coil, using the Litz as a generator, and we're going to try and find the resonant frequency of this black one on the top. Okay, let's keep it on there. 77.7. That's lucky.
Josh Hammond is in the house.
What's up, Josh? All right. So we'll go up. That's good. That was a good move. Up again. Nice. And then once we hit that frequency, we'll hook it up to the battery. $369. Okay, that isn't it though. We're close though. Maybe. 100 volts. 100 AC volts coming off of 5 DC volts and 1 amp. So coming off of 5 watts. We're getting that. We're gaining like 2 volts every hertz. 2 to 3 volts. $381.
2,000 views.
Oh, nice. All right. $125. This is gonna be different. I think we need to move up to like 400. Let's keep it coming. Alright, we are overloaded. 203. Wow, man, it is like super accelerating right now in the voltage. 406 hertz. 406 hertz. Wow, that's amazing. That is like 309 AC volts off of 5 DC volts. Let's just call it 5 watts. This is 5 watts. .420 hertz. Alright, we might be there. 365. Holy smoke. Let's go one more. Okay, we're not there yet. Okay, we're there now. 366. 365. Go back up, come on. So 427, 426 is the resonant frequency. And at 427, it did want to go to 366, but it went back down. So I'm gonna hook it up now. I'm gonna hook it up, hook it up. So we'll watch it on the DC side because it's more cute. Now the fact that it is drawing a whole amp on a bunch of 38 is pretty awesome. I mean, it is a lot. It's an 18 gauge strand worth of 38 though. So it makes sense to me in that respect. I'm gonna do a 9-volt battery if I can get it there. Yeah, 9 volts. We're drawing 1.177, 1.1, 1.2 amps at 9 volts. And this battery used to be dead, like not workable. And I think it's been revitalized pretty much. And apparently the SSG circuit without gen mode doesn't clip as hard as the other one does. And that doesn't make sense to me. 'Cause it's supposed to move. But them to combine, woo wee. So we'll open it up all the way. So this is SSG without gen mode. And we'll run a little comparison. Because the circuits are identical. They're just all shoved in the same bobbin. Or the coils, I should say. 738, 764, 787, 805, 821, 834, 846, 855, 864, 870, 877, 882, 886, 890, 893, 897, 899, 902. So that's reaching its plateau, I think, and where you start playing with the resistance. Right now, this is like no resistance. 906. Put like 3/4 of a turn of resistance. 1100. Oh no. 984. 989. 992. 1000. And that's just with 3/4 of a turn of resistance on a 10-turn pot. That's awesome. That's awesome. Wow, that just the speed of this thing is gonna blow my mind. 1051. That's awesome, man. I'm freaking charging a battery with the solid state generator. That's so cool. And it turns out that the Litz wire coil this small makes a better generator than a pickup coil. By a long shot. Like, immeasurably better as a generator. Because I tried it the other way and it literally doesn't work. It's because it's so small. It's really a small coil, like 50 turns of 18 gauge thickness of Litz wire. So it's really a small coil. And it draws amps like it's an 18 gauge wire. So a little, just imagine a little tiny 18 gauge coil pulsing in its electromagnetic field into this coil. But it's split into 100 little pieces. Ooh. That's freaky. That's a lot of power right there.
Power.
And everybody's, I can understand where you're coming from. What if you can get, if this Litz wire coil was the size of this one, maybe that would be a thing. Maybe we could get some nice generation off of it. But since it's so small, it just doesn't work the way you would think it would. Wow, it's only going down like 1 RPM every time it does the measurement. So that means that it's got better flywheel capabilities than it did before. Apparently, we've hit a snag. It's not going up anymore. Maybe, well, it's going to take longer now. I wonder what's going on. And if we bump into this problem all the time, it reaches up to a certain point and then it just stops. Or it slows down to a speed that is not practical. And then you would say, yeah, this is the time where you go mess with the knob over on the frequency generator. But I'm telling you, resonant frequency is probably resonant frequency. And messing with it is going to make it worse either way you turn the knob. So, I don't know what it is. I think this is where the battery starts pushing back and you get it like the energy, because there's nothing forcing this to go that way. It's just it was naturally, no, actually, what was forcing it was me putting the 9 volts into the coil. Maybe this is it. Nope, there it goes. Oh! It's going slowly though. Very slowly. And I did mention that practicality now is an issue. But, I mean, some cell phones charge really slowly. 12 volts. Let's see what we get out of that. It's going up a little faster. We are drawing now 1.3 amps. 12 volts. This is my max. This is as high as I'm going to turn it up. And I was hoping maybe to get to 11 or something, but that isn't going to happen. It is going up a lot faster now, though.
So Jason dropped in and said, how you doing? What are you doing?
This is a pulse motor. I'm calling it Project M.P.H.JR, or miles per hour junior. So it's virtually 2 rotors smooshed together, that it's held together by the neodymium cubes. That isn't how I put it together though, but that's what it's ended up being. So that's what I'm going to say. It's a dual drive. So you got your 2 20 gauge drive strands that go, one goes here to this SSG, and the other one goes here to an SSG with gen mode. Okay, each one of these has a potentiometer, and each one is a closed loop system to these 20 amp hour batteries. So the input and the output are both connected to this battery. But the output first is connected to a cat bank and then to the battery on both sides. So both sides do this, both sides charge and draw from the same supply to and from. And then there's two trigger coils in this as well. So each unit gets its own coil, but it's all put into this coil. So when they're both on, both resistance or both pots will affect both motors. Okay, well, it will affect their outputs as well. So combining the two actually gives some benefits of one to the other, and so on and so forth. This one adds more speed, this one adds more generation, and yes, they are combined inside of this coil. There's enamel on the wire, but that doesn't mean that they're not combined through proximity. They're definitely feeling each other, if you know what I'm saying. Alright, I guess we could fire it up. Alright, I'm going to turn this down. I can smell the transistor getting hot over here.
Yeah, the testing.
You can hear it now, man. It gets so powerful that it pushes the permanent magnets up when they pass by. And that's the boost that you're getting right there. Seven 784, 798, 807. $872, 908, 938, 991, 1012. And it's really starting to pick up now. Here we go. You can feel the torque on this thing right now. And it's like, and that's with it being off. Like what was there, you can kind of feel that. And it's like skin by hand.
Yeah. Wow.
Oh, dude, that was going pretty fast. If I would have let that shaft go though, nah, I wasn't gonna do that. Boom.
Oh.
What's your question?
What are we doing? Oh, Josh said, I just took apart a micro cassette motor. The only thing that holds it together is its powerful field magnet. Nice.
saying it's probably good.
Yeah.
My magnets holding together.
2,500 views.
Awesome. Hell yeah. So I think what I'm gonna end up doing is buying a lot of components. Cause I got a lot of physical issues that prevent me from doing the fine motor. And I think the most that I wanna, like soldering, I'm not gonna be able to do that. My vision's bad. I have a tremor. It's violent too sometimes. Like, you ever watch Saving Private Ryan? You know, like my tremor is violent sometimes. So God willing, with the help of some compatriots, maybe I can start experimenting with Tesla coils and things like that. Until then, you know, it's gonna have to be a little bit more of a broad stroke, for me, anyway. Yeah. It's not gonna be able to be all micro tight and like that, cause I will try my ass off to do it for like a whole day. I'll just be there like holding my one hand like this and going in there like that just to get that one thing where it needs to be, and it's just not worth it to me anymore to do it myself. You know, I mean, if there's a really easy way to do it that doesn't involve a lot of fine motor, I'm game. I will do it. And yeah, I'm talking about building a Tesla coil and playing with circuitry of high voltage. I wouldn't trust myself doing that because, yeah, I'm not the sturdiest hand. But, you know, I could probably, I don't know, put it together or hopefully just buy one. You know, eventually get enough money together to buy one. I mean, my subscriptions that I had have all expired because of lack of funds, but I just managed to get one back up today. So that's good. I like supporting the people that I like and appreciate, and that's pretty much everybody that I've met so far. I mean, everybody can like get picky about stuff, but why? Why would you waste your time building fences? You know, when reality is there is no fence. You know what I'm saying? I'm not going anywhere. I'm pretty sure that, you know, people are, as long as, you know, we're still breathing and kicking, we're not going anywhere. And I don't see any reason why that should change. I don't know if everybody sees eye to eye with me on that, but that's how I feel about it. And yeah, man, the spinny part is never going away, man. I love the spinny part. For me, it's always going to be here. I gotta have something that's moving or spinning or pumping like a piston and the spring action. Something's got to be moving, or it's not perpetual motion. I'm just kidding. Now, if you're just looking for over unity, which is, I guess, something, it's along the lines of the same thing, but it's different because there's motion involved in this, which I don't know whether it takes more or less energy to make something move than to just not make something move. So perpetual motion would definitely be different than over unity. in my mind, two totally different things, and they should not be confused with one another. This is not perpetual motion. This is just a badass system that will probably end up going, like if I get it down on the ground, up to 2,000 RPMs without a problem. And that's in a radial form. Right now it's axial flux. Right now I think it could get up to like 3,500 if we let it just build up. And if we play with the resistances and we outboard this thing as much as we can, I think 3,500 with the axial flux. And see what's cool about it, this design, is that there's two cubes at every 120. So like this 120, there's two cubes and they're both facing down. So our north is facing down. And then here, there's another north facing down. But there's two in each spot, so they're doubled up. And that makes it so when it's on and it's close enough right now, it's like a centimeter away. When it's on, it will actually physically bump the rotor up when the magnet passes over it, because now the energy from the magnet is twice as strong. And it's just, you can just tell the difference in power by having those magnets doubled up. Now you can just skip all the fancy stuff and get, a magnet that's the size of two magnets. You could do that. But usually those are divided the long way and not the way that would fit in here. Okay, so it would be like this and not like this. For most of them, I'm not saying all of them are like that. You got to really pay attention to the way, especially when you're not dealing with a square or something flat like this, when you're dealing with like a rectangle, how they are, a toroid magnet even, how they divide, how they align the magnetism in the object. It's real important to pay attention to that, because some of them are special. Some of them are made to do things that are different simply by, dividing the north and south line differently, different orientation in the magnet. Because I got involved with like some like circular, but it was like pieces of pie, and it was like more of an octagonal shape, but you just put a bunch of wedges together and it made an octagon. But yeah, those were cool. Not exactly what I'm talking about though. Yeah, I can just use this to demonstrate. I'm sure you guys have already caught on, but I'm just going to demonstrate it. This is the north side. This is the south side. What I'm talking about is having like the top of it be the north side and the bottom of it be the south side. You know what I'm saying? By splitting it in a different orientation, the magnetism can be used in different ways. But usually it's going to be split the easiest way that it can be split, because it probably doesn't, it's probably not cheap to make a magnet, honestly. I mean, you could make a magnet easily in like your living room or something with a setup that's designed to do that. But we're just talking order of magnitude here. There's no apocalypse that's happened yet, so I say, what the hell, man? Let's buy them up. Make them in the factory, and let's buy them up, because you can get them that way, or you can make them yourself. You can do that, you know, you can magnetize stuff by using, I don't know, electromagnetic waves, maybe microwaves of some kind. Some waves. Don't really know anything about it, but I know that you can do it. I've seen videos about people doing it. But yeah, especially if you need something like this toroid, for example. You know, it's split down the center like this. So you got a north side and a south side. But if you split it down the center like this, and this becomes the north side, and this becomes the south side, and it's split like that. Why don't they make them like that? I mean, do they make them like that? And you just need to order them specially? I mean, I see that as being more powerful than having it the other way, because then you get all that force in the middle. You can spin something, or you know, do something in the middle of that. Or you know, when you buy it or when they make it, have it be two toroids, one going, and have it be perpendicular, right? And then have them put a shaft through the middle too, just for good measure. But you can have the faces be normal. You can have it just be cut in half like that, and then have it be perpendicular, and it would spin like this. I think Old Man Built the motor like that, like maybe patented it or something. I'm not sure exactly, but he put the 4 rectangle N52s in there, and I just think that the toroids with the perpendicular kind of remind me of that. If you put a shaft down the center. But nobody makes magnets like that. That's like a very special order. It's a tall tale, man. It doesn't happen anymore, or it never did.
We got your mic volume is quite low. I wanted to, we gotta find those things.
It might just me be talking low. Let me turn that up. Let me zoom in a little bit too, because then you might be able to hear me better. Because I got 2 tones really. Is that any better? It's raining again. Awesome.
Much better.
All right, cool. I was standing right next to it a second ago, but is it better now? Oh, it's all right.
Yeah, the mic is too low again, too far away.
All right. Thanks for letting me know. There's not really much I can do about it right now, but we'll get some extra mics. All right. So, man, all right, we are not good. One of our meters is dead. I had some stinking coming off the transistor. I want to see if that is still working or not. It looks like it's working still.
You just gotta turn it up loud, so just let them know if you're gonna set up the Tesla coil, so we can turn it down.
All right. I'm gonna turn on the motor real quick, and then I might reach over here and turn on the Tesla coil. Now that it's raining again, people won't be able to hear it as well. So you can hear it push. And then an excellent boost of speed, and then it just increases. It's amazing. Wow, that's going so fast. So neat. I think if I don't touch it, it might not start shaking. We'll see. I'll keep my eye on it. Very slight tremor right now. So it might have settled into a quasi-normal state and not rampant acceleration. Let's see. $832. Another 3/4 turn of the resistance. $900. $916. So I think we definitely need to tighten the shaft down a little bit before we play with it anymore. That is so powerful, man. It's like literally yanking the screws out. Ooh, man, I made it work, and it works. But we won't be doing that again today. And that's how much we got off of the 3 volts input off the solid state. So that's been working. That's good. Solid state is probably going to be the way to go in the future. But I'm going to keep my rotors, man. I'm going to keep them all around. But yeah, man, it's always a pleasure. So thank you very much. Peace out. Have a wonderful day or evening, night. Bye now.